Hi everyone, welcome to Design and Technology channel. In this video, we'll be discussing the parabola, how we go about its constructions and all. Uh, the parabola is one of the loci that we'll be uh, talking about this term, and today we'll be talking about we'll be seeing the demonstration on how to construct the parabola. But first, we need to know what a parabola is. What's a parabola? It is the locus of a point which moves so that its distance from a fixed point called the focus and a fixed straight line called the directrix are always constant. And this distance is known as the eccentricity of a parabola. And the eccentricity of a parabola is equals to 1. So we have different methods of constructing the parabola. Basically, three methods. We have the locus method, that the use of locus, uh, and then we have the rectangular method, and we have the parabolic envelope method. So we'll be demonstrating these three methods, not in this video, in subsequent videos. We'll be demonstrating this three methods. So this is what the parabola looks like: a curve that just runs from the top like a projectile motion. So you can see that it goes from this point all the way down here. So we need to know the characteristics of a parabola so that when we are given a question or a task to construct a parabola, we'll know what we should be looking for in a parabola. So the parabola has a focal point. You can see it F. It's on the axis. Now this line is called the axis of the parabola, AX, AXIS, the axis of the parabola, this line here. So it divides the parabola into two, and it runs from bottom to the top of the parabola. And then this point marked V here is called the vertex. It's called the vertex. That is the highest point of the parabola. So the parabola doesn't go beyond this vertex. So when it gets to the vertex, it starts falling downward. Then another important part of the parabola you need to know is the span of the parabola, where the two roots of the parabola ends. So from this point to this point is the span of the parabola, how wide the parabola would be. And then the height of the parabola, that is from the vertex to the roots, from the highest point to the lowest point of the parabola, indicates the height of the parabola. And then we also have a point called the directrix. It's a line drawn above the vertex. The directrix is a line drawn above the vertex. When you are given a task to construct a parabola using the locus method, you'll be needing the positioning of the directrix as well as the focus. So when we get to all these methods, you will see how we get to make use of them in constructing the parabola. But for this demonstration, I want us to construct using the rectangle method. I think this is the most common, it's commonly used, and it's easier, very, very easy than every other method of constructing the parabola. So we'll be doing the rectangle method, and for a rectangle method, to make use of the rectangle method, all you need to know, the parameters you need to construct the parabola is the span and the height, the span of the parabola and the height of the parabola. This span and the height would help you form the rectangle that is needed to construct the parabola. Now let's move on to construction of parabola. When given the span of 90 millimeter, that's 9 centimeter, and a height of 80 millimeter, that's also 8 centimeter. What is expected of you to do at this point is to construct a rectangle. Since you're using a rectangle method of constructing a parabola, is to construct a rectangle whose length will be 90 millimeter and the height would be 80 millimeter. So the length of the rectangle helps us to accommodate the span of the parabola, while the height of the rectangle helps to accommodate the height of the parabola. So we'll move on to construction of the rectangle. You can use any means to construct a rectangle. You can make use of a set square and ruler, provided you have all of the sides of the rectangle accurate. So this is my rectangle that spans 90, and then the height is 80. So I have it here, 90, and the height of my parabola being 80. So we have the height of the rectangle to be 80, and the length of the rectangle to be 90, and the height, the breadth of it to be 80, because of the parabola specification that was given to us. So please pardon my rectangle. My grid lines are not accurate enough, so my rectangle has to have this little uh, intersecting clearance here. So basically, let's focus on the rectangle and work out what we want for the parabola. So the first thing you need to do when using the rectangle method of constructing the parabola is to divide your rectangle into two equal parts. So I'm just going to divide my rectangle into two equal parts. So I measured out 45 on this side, and then I'm having a straight line running upward. So let me call this part E, A, B, C, D, E. Let me call this line E and F. So this is F and this is E. Now the next thing you need to do is to divide line DF. Divide line DF into equal parts, as well as line FC. So remember, when you're making divisions to construct a locus, the more your divisions, the more your points of divisions and intersection, the closer and more accurate your locus will be. So for the purpose of this demonstration, I'm just going to divide this DF into 4 equal parts. So I'm going to transfer